Ever wondered how machine learning handles high-dimensional data? High-dimensional data, in a nutshell, refers to data sets with a large number of features or dimensions. Picture a complex web of information, where each thread represents a different feature. This might sound like a goldmine of insights, but it's often more of a challenge than a blessing. This is due to a phenomenon known as the curse of dimensionality, which essentially means that as the number of features or dimensions increases, our ability to extract meaningful insights decreases. It's like trying to find a needle in an ever-growing haystack. Enter dimensionality reduction, a technique that simplifies this high-dimensional data. It's like a map, condensing the sprawling city of information into a digestible, useful format. By reducing the number of random variables under consideration, we can focus on the important features and make our machine learning algorithms more efficient. So, dimensionality reduction is our knight in shining armor when it comes to dealing with high-dimensional data. Now, what exactly is this dimensionality reduction? Glad you asked. Let's break it down into digestible steps. Picture a data set as a multi-dimensional space, with each dimension representing a variable or feature. But here's the catch. When we have too many variables, it can be extremely challenging and time-consuming to analyze or visualize this data. This is where dimensionality reduction comes into play. Dimensionality reduction is like a master chef who expertly trims away the excess fat, leaving us with the juiciest part of the steak. It reduces the number of input variables, or dimensions, in a dataset, while trying to retain as much valuable information as possible. Now let's get to know the two main types of dimensionality reduction techniques: feature selection and feature extraction. Feature selection is like choosing the best ingredients for your dish. It selects and keeps only the most important features, discarding the rest. On the other hand, feature extraction is more like blending all the ingredients together to create a new, combined flavor. It transforms the existing features into a lower dimension, creating new composite features. So why do we do all this? Well, dimensionality reduction helps us simplify our high-dimensional data, making it easier to work with and understand. It's like turning a complicated, hard-to-read map into a simple, clear guide. In a nutshell, dimensionality reduction techniques help us simplify our high-dimensional data without losing much information. Why should we care about dimensionality reduction, though, you might ask? Well, the benefits are multifold. Firstly, it can significantly improve the performance of your machine learning model. By eliminating irrelevant features or noise, it allows the model to focus on the crux of the information, thereby enhancing its accuracy and efficiency. Secondly, dimensionality reduction can dramatically cut down on computation time. With fewer dimensions or features to work with, your model can process data much quicker, saving precious time in our fast-paced world. Thirdly, it helps in data visualization. When we reduce high-dimensional data to 2 or 3 dimensions, it becomes far easier to visualize and understand the data's structure and patterns. Lastly, dimensionality reduction makes the data more manageable and understandable. It simplifies complex data, making it easier for you to make sense of it and draw meaningful insights. Clearly, dimensionality reduction is more than just a fancy term. It's a crucial part of efficient machine learning. Let's quickly recap what we've learned about dimensionality reduction. We've discovered that this powerful technique is an answer to the challenges posed by high-dimensional data. When we're dealing with a vast number of variables, we can easily be swamped by complexity. This is where dimensionality reduction comes to the rescue. Dimensionality reduction is all about reducing the number of input variables. It's like distilling the essence of the data while discarding the noise. We're not just simplifying our data, we're also making it more manageable, and more importantly, more meaningful. We've also discussed the numerous benefits of this technique. It helps to speed up machine learning algorithms, making them quicker and more efficient. It can also help to eliminate redundant or irrelevant features, improving the accuracy of our models. Moreover, it facilitates data visualization, allowing us to better understand and interpret our data. But let's not forget the fundamental principle behind dimensionality reduction. It's not about reducing dimensions for the sake of simplicity. It's about making machine learning more efficient and effective. It's about extracting the most valuable information from our data and using it to build better, more accurate models. Remember, the goal isn't to reduce dimensions for the sake of it, but to make machine learning more efficient and effective. That's the power of dimensionality reduction.